In this presentation, we're going to talk about solving exponential equations using either the principle of exponential equality or the principle of logarithmic equality. We'll go over what that means in just a minute. In order to be able to complete this section, you do need to know your basics for exponents as well as your basics for logarithms, including your properties of logarithms, mostly the power rule. So the other day in class, we talked about the principle of exponential equality, which says that if your bases are the same, then your exponents have to be the same, meaning that we can go ahead and just cancel our bases. This works both ways. If x equals y, then you can also put both of these up in exponents and you still have an equal statement. The principle of logarithmic equality is kind of the same idea. If your bases are the same on your logarithms, then the insides have to be the same. Now, when we work in this section, we're mostly going to be starting with something of this form, and we can take the log of both sides. So the basic idea that we have here is just like when we've looked at all of our other functions. In order to get rid of addition, we use subtraction. We use the opposite. To get rid of multiplication, we use division. To get rid of square roots, we use squares. Similarly, to get rid of squares, we use square roots. And so we're going to add to this, to get rid of an exponential, use a logarithm. We're going to need to know our properties of logarithms, as I said, the power rule. And then we're going to use our other techniques that we have already discussed in order to finish solving. So let's look at some examples of this. Before we jump into examples, we are going to need to know how to do these on our calculator. And so some of the key buttons that I want to point out, if you are trying to create an exponent, you want to use the caret key. If we are using logarithms, you have two on your calculator. You have one that says log, and this is log base 10. You also have ln, which is natural log, which is log base e. We didn't get around to what e is, but e is basically a number similar to pi. It is a irrational number, and as you progress through your math classes, you may see it again as you progress up to calculus. So we're going to look at solving exponential equations here. Now some of these we can use using the property of exponential equality, meaning that if we can write with the same base, then we can go ahead and set the exponents equal to each other. The principle for logarithmic equality, we're going to use that in case we cannot get the same base. It's not always possible to rewrite these with the same base, and so we are going to use our logarithmic property of equality and then move our exponent down to the front using the power rule. From there, we can finish solving. So, we still need all of our linear techniques in order to solve as well. So if we look at example A, we have 3 raised to the x minus 5 equals 27. And the first thing that I want to do is analyze this and see, can I write the left and right side with the same base? And it turns out that yes, I can. 27 is 3 to the 3rd power. So my first step is going to be rewriting 27 as 3 cubed. As we saw in class the other day, from there we can cancel our bases and we are left with x minus 5 equals 3. In order to finish this problem off, we just want to finish solving for x using linear techniques. Notice now that we have no exponentials, and so in order to finish solving this, I just need to add 5 to both sides. We get x equals 8 as our final answer. And we're done. All right, so let's come over to example B. Example B, we have 4 raised to the x equals 20. And so one of the first things to note about this problem is 20 cannot be written as 4 raised to some exponent. 4 squared gets us to 16, 4 cubed gets us to 64. There's nothing there that will get us to 20 using nice numbers. So this is an example where we are going to have to use logarithms. So the first thing I want to do is take the log of both sides. Now in the previous slide, I mentioned that you have the log, just regular log with no base, or you have natural log, the ln on your calculator. Doesn't matter which one you use as long as you are consistent. I'm going to go with just log and make sure that I have it on both sides. So from here, we can use our power rule and bring our x down to the front. And we get x equals log of 4 equals log of 20. Now I know that we are new to logarithms, but one thing to keep in mind is when you see something like log of 4, log of 20, these are ultimately just numbers. So if you have x times a number equals another number, how do you get x by itself? Well, remember that to get rid of multiplication, we use division. So I want to divide log of 4 to both sides. On the left it cancels, leaving me with x equals log 20 over log 4. So now when you put this in your calculator, which you will have to do, remember those buttons that I showed you? What you should have when you plug it in is log. It'll open up a parenthesis for you. You're going to type in 20. Make sure that you close the parentheses. Divided by, which will come out as a slash, log. Again, it'll open a parenthesis. Plug in 4 and close it off. Which according to my calculations comes out to be 2.1609. I'm going to round it up to 2.161. Okay, so we have that one. Let's go ahead and look at another example. We have 7 to the x minus 2 equals 60. So same thing, there's no way to write 60 with a base of 7, so we are going to have to use logarithms in order to solve this. So I'm going to take the log of both sides again. We get log of 7 to the x minus 2 equals log of 60. I can move all of the x minus 2 down to the front. Make sure that you have it in parentheses because this whole thing is being multiplied to log of 7. We bring down everything else. So I get x minus 2, that whole thing, times log of 7 equals log of 60. Just like on the previous problem, you can either distribute or we can do what we did on the previous problem, which is divide both sides by log of 7. They cancel on the left. We are left with x minus 2 equals log of 60 divided by log of 7. From here, if you want to compute this first before continuing, you can do that. But I'm going to go ahead and just add 2 so that I have my exact answer. And it does look nasty. We get x equals log of 60 over log of 7, all of that plus 2. When we input this in our calculator, it should look something like this. Log of 60, close your parentheses, divided by log of 7, close our parentheses again, plus 2. Which should result in a final answer of 4.104. And we're done. Let's look at one more example. For example D, there's nothing like this on the homework, but just to show you kind of how this relates to what we've done in the past. So the first thing that I want to do is, just like we did when we talked about solving square root problems, the first thing that I want to do is I want to move anything outside of the exponential thing to the other side, which means I want to start by subtracting 5 from both sides. We get 2 to the x minus 4 equals 32. Now in this one, you can go ahead and use logarithms to solve, but 32 is actually can be written with a base of 2. So I can write this as 2 to the 5th. As our bases are the same, we can cancel them. We are left with x minus 4 equals 5. And in order to finish solving this, we want to add 4 to both sides. We get x equals 9. And we're done. Now, as far as some of the weird things that we've been looking at lately, we've been looking at rational equations, we've been looking at radical equations, and this is another new one. One thing to note is, if you recall, I briefly mentioned that the domain for exponentials is all real numbers, which means that there are no problem spots. That means that you do not have to check your answers except for to check your answers. You're never going to run into any problem spots. If it doesn't work, then that is because you did something wrong. So hopefully this makes a little bit of sense in terms of solving exponentials. The next thing that we're going to look at is solving logarithmic equations.